Welcome to my class 12 physics. Today we will discuss a new topic, that is your electrostatic potential due to electric dipole on the axial line. But before discussing this topic, let us recall about the meaning of the electric dipole, what is axial line and what is equatorial line. First thing, that is the electric dipole. What is electric dipole? Dipole means two poles are there. That means we take here 2 point charges, one is minus q, another is plus q. Minus q charge is situated at point A and plus q charge is situated at point B, and magnitude of the both the charges are same. That means magnitude of the minus q charge, that is q. Similarly, magnitude of the plus q charge, that is also q. Both are having same magnitude, that is q. But nature is opposite. One is negative and another is positive. That means we take 2 point charges having equal magnitude and opposite nature. And this one is the distance between the two charges, that is A to B. This distance here we write, that is the twice of A, and that is electric dipole. That means simply if we take two equal and opposite charges separated by distance, that is known as the electric dipole. And you know the axial line. This is the line passing through the minus q charge, plus q charge, and center of the dipole is known as the axial line. You know that. But here equatorial line means line passing through the center of the dipole, this line, and perpendicular to the axial line. Line passing through the center of the dipole and perpendicular to the axial line is known as the equatorial line. And you also know the electric dipole moment. Dipole moment means we write symbolically, that is P, that is equal to product between magnitude of any charge, that is Q, and the distance between the two charge, that is twice of A. That means product between magnitude of any charge and the distance between the two charges is known as the electric dipole moment. Clear? Now we will discuss, that is electric potential due to electric dipole on the equatorial line. So that first we draw the diagram or figure. This one is the diagram. Here we take two charges, one is your minus q charge and another is your plus q charge. Minus q charge placed at point A. This is the position of the first charge, that is the minus q charge. We take another charge, that is the plus q charge placed at point B. That is the electric dipole, and this point is the center of the electric dipole. We write that is O. From center of the electric dipole up to the position of the minus q charge A point, this distance is A. Similarly, from the center up to the position of the plus q charge, that is also A. That means A plus A, that is the twice of A. And we draw the equatorial line. This line is the equatorial line. We take a point P on the equatorial line. Distance between the center of a dipole up to the observation point, this distance always write R, that is OP. That is OP. OP is equal to, that is R. That means simply at point P, because P point is the observation point, at point P we will calculate electric potential due to electric dipole. So that first we calculate at point P electric potential due to minus q charge. We write that is V minus. Similarly, next at point P we will calculate electric potential due to the plus q charge. We write that is V plus. Here distance between the minus q charge, and the observation point is equal to this distance, that is AP. Then what is AP? Here this one is a right angle triangle, AOP. Triangle is AOP triangle. From this triangle, this is a right angle triangle, you know, square of this side means AP square is equal to AO square plus square of this side, that is OP square. That implies we write AP square is equal to AO square, that is A square, plus OP square, that is R square. Then what is AP? We write AP is equal to square root of A square plus R square, or we also write this is equal to square root of R square plus A square. This is AP. Here it has same thing, distance between A to P, that is square root of R square plus A square. Similarly, same thing, distance between the position of the positive charge and observation point, that is also square root of R square plus A square. Now, we will calculate electric potential at the observation point, first due to the minus Q charge, then due to the plus Q charge. So that we write the expression of the electric potential. The expression of the electric potential V is equal to 1 divided by 4 pi epsilon 0 Q divided by R due to a point charge. This is the expression of the electric potential at any point due to a point charge. We have discussed this in the previous class. That means, suppose you take a source charge, this charge is plus Q, this point is the observation point, that is P point, this distance is equal to R, then at point P, this is the expression of the potential. We know that. So that we write electric potential at point P due to minus Q charge, that is the V minus is equal to 1 divided by 4 pi epsilon 0, charge is minus Q, so that we write minus Q divided by distance, distance is AP. This is the expression. This is the expression of the electric potential due to the minus Q charge at point P. Similarly, expression of the electric potential at point P due to plus Q charge, we write V plus, same expression, we write 1 divided by 4 pi epsilon 0, charge is plus Q divided by distance, that is BP, we write BP. Here charge is minus Q, so that we write minus Q. But in this case charge is plus Q, we write that is the plus Q, because potential may be positive, may be negative, that depend upon the nature of the source charge. Clear? Then what is the net potential at point P? Here we applied the principle of the superposition. So the net potential at point P is equal to sum of V plus and V minus. In place of V plus, we put equation 2. In place of V minus, we put equation 1. That means V plus is equal to 1 divided by 4 pi epsilon 0 plus Q divided by BP. In place of BP, we write this one, square root of R square plus A square. And in place of V minus, we write same thing, 1 divided by 4 pi epsilon 0 minus Q divided by AP. This one is the AP. In place of AP, we write square root of R square plus A square. Here one term is positive, another term is negative, both are having same magnitude, so that total resultant is equal to 0. That means finally we get electric potential at the observation point, electric potential on the equatorial line, electric potential on the equatorial line at the observation point means at point P is equal to 0. Suppose this point is the P point, this point is also situated on the equatorial line. Here also electric potential V is equal to 0. Suppose you take another point, this is the observation point, this point is also situated on the equatorial line. Here also electric potential is equal to 0. That means finally we get electric potential due to electric dipole on the equatorial line, that is equal to 0. And this is all about your electric potential due to electric dipole on the equatorial line. And in the next class, we will discuss about another new topic, that is electric potential due to electric dipole. Clear? Thank you.